Hello friends and welcome to Login Science. In today's video I'll be talking about sequences and series, and this is our first lesson, so it is lesson 1 of 6. So before I can start, just make sure that you subscribe and activate the notification button so that you can be notified every time I post a new video. And I would like to see your comment, your likes to encourage me to be posting new content. Okay, so today's today's lesson is sequences and series, and let's start with number patterns. So a number pattern or a number sequence is a list of numbers in order. So it is a list of number having a certain behavior, if I can put it that way. So we need at least 3 numbers in the list to decide if the numbers form a pattern. So you will need at least 3 numbers in a list to decide if the numbers form a pattern. And we say a pattern is a list of a number having a certain behavior. So a list of numbers in a certain order, having a certain rule, if I can put it that way. Okay, let's see one example. Okay, we are going to look at an example to see if the following list of numbers is a pattern. So let's see example number 1. So when you observe, we have a list of numbers. Is it forming a pattern? At least we must have 3 numbers to decide. Okay, we have 4 numbers, that is enough. And when you observe, there is an order or there is a behavior which is done to get the next number. So to get the next number, what they are doing is to add 5 to the previous number. You can see from 3 to 8, you add 5. The same is true from 8 to 13, you add 5, and so on, you add 5. So this is the pattern which is obtained. You add 5 to get the next number. You add 5 to the previous number to get the next number. And the first number in the sequence or in the pattern is referred to as T1 because it is the first one. And the second one is T2. The third one is T3, and the fourth one is T4, and so on. So we can also say any number in the pattern is represented by T subscript n or Tn. So this is the general term that is representing any number in the pattern. So we'll say that Tn is the nth term in a pattern. Or in a sequence. Okay, so let's do another example and see how a pattern can be formed. Okay, this is another pattern. As you can see, there is an order or there's a certain behavior which is observed in this pattern. To get the next number, what they are doing is to multiply by 3. So from 5 to 15, you multiply by 3. And from 15 to 45, you multiply by 3, as you can see. And 5 is also referred to as T1, 15 is T2, and 45 is T3, and so on. Any term in the sequence will be designated with Tn. So we can see that. So this is a pattern which is observed here. They are using 3, a multiplication by 3 to get the next term or the next number in the list. Okay, so you'll come across different type of patterns as we move on. Okay, now let's move on to arithmetic sequences. So an arithmetic sequence is a sequence where the common difference denoted by D between consecutive terms is constant. So arithmetic sequence is a sequence where the common difference between consecutive terms is constant. And the common difference so the common difference is obtained by taking the next number minus the previous number. As you can see, T2 minus T1, which is also equal to T3 minus T2. So the next number minus the previous number will give you the constant difference or the common difference for an arithmetic sequence. And this is written as T subscript n minus T subscript n minus 1. So this is the next number minus the previous number. You can see the next number minus the previous number. You can see the next number minus the previous number. It will be equal to D, which is the common difference, and that common difference is constant for an arithmetic sequence. Again, we say that an arithmetic sequence is a sequence where the common difference between consecutive terms is constant. Okay, now let's move on. Okay, we have example number 3. The question is, given the arithmetic sequence 5, 9, 13, 17, question A says determine the common difference, and B, determine the next 2 terms. So remember from the previous example number 1 and 2, we were trying to see if the list of numbers was a pattern. And in example number 1, the pattern was an arithmetic sequence, and in example number 2, the pattern was a geometric sequence. Okay, you'll be seeing about geometric sequence in the upcoming video. For now, we are talking about arithmetic sequence. Okay, now let's solve for example number 3. Okay, question A, determine the common difference. So since we are told that it is an arithmetic sequence, to find the common difference, we just take T2 minus T1, which is also the same as T3 minus T2, or T4 minus T3. So the common difference is T2 minus T1, which is also the same as T3 minus T2, which is also the same as T4 minus T3. And that is 9 minus 5, which is equal to 4. So you can still use 13 minus 9 or 17 minus 13, you still get 4. So the common difference is 4. So 4 is added to the previous number to get the next number. Okay, now question B, determine the next 2 terms. So the next 2 terms that is the terms after 17. So it will be 17 plus 4, and the other one will be, we don't know what it is. First we need to find this one. It will be 17 plus 4, it is 21, and the next one will be 21 plus 4, so it will be 25. So the next two terms will be 21 and 25. So that is the answer to question B. And let's move on. Okay, so there is a general formula for the general term for the arithmetic sequence. So this is the general formula for the general term for the arithmetic sequence. It is Tn is equal to A plus, in bracket, you open, you close, you have n minus 1 in bracket times D. So A is your first term, is the first term, and A is equal to T1, which is the first term, and D is the common difference, that constant difference of the arithmetic sequence is D, and N represents the position of the term in the sequence. So you can use this formula to find the term in the sequence or to find the general term of an arithmetic sequence. Okay, let's do two examples so that you can understand how to use this formula. Okay, now we have example number 4. Let me read the question. Given the arithmetic sequence 4, 10, 16. Question A, determine a formula for the nth term of the sequence. And question B, calculate the 50th term. And C, which term of the sequence is equal to 310. Okay. A, we are told that the sequence is an arithmetic sequence, and what we want to find is to find a formula for the nth term, or the formula for the general term. So this is the formula that we need. You remember this formula? This is the one we need to find. So what we'll be doing is to replace only A and D. So in our case, A is the first term, and that is 4. So A is equal to 4, and D, to find D, we take the next term minus the previous term, that is T2 minus T1, or T3 minus T2, because it is an arithmetic sequence. We are told that it is an arithmetic sequence. So 10 minus 4 will give you 6. The same is true. 16 minus 10 will give you 6. So I can just say D is equal to 6. And then we replace that in that formula. So Tn is equal to A is 4 plus N, we leave that, minus 1, and D is 6. So Tn will be equal to 4, 6 times N, and there is a positive there, so it will be 6N. 6 times negative 1, it will be negative 6, and Tn is equal to 6N, and 4 minus 6 will give you minus 2. Okay, so this is the formula for the nth term of the sequence. That is Tn is equal to 6N minus 2. So to get any term in the sequence, you'll need this formula. Okay, now let's do question B. Let me erase this space. Feel free to pause the video. So question B is to find T50 because it says calculate the 50th term. So T50 will be, we'll still use this formula that we calculated from question A. So T50 will be 6 times, in the place of n, you put 50 minus 2. So this will be 6 times 50 will be 300 minus 2, which will be 298. So this is question B that is solved. Okay, so like I'm saying, feel free to pause the video if you are following behind. Now let's do question C. Question C, which term of the sequence is equal to 310? So what question C is asking is to find T, what, question mark, I'm putting a question mark there. So T what is equal to 310, or what is n equal to when the value is 310. So 310 is also a term in this arithmetic sequence. So we want to find the position of 310. So we can find the position of 310 by solving for n. And remember, we're gonna use the general term that we calculated previously, and it was Tn is equal to 6n minus 2, if you remember from the previous question. So let's solve for n. So we're gonna replace this Tn with 310. So 310 is equal to 6n minus 2. And then let's solve for n. So I'll bring my negative 2 to the other side of the equal sign. So it will be 310, negative 2. When it moves to the other side, it becomes positive 2. And on the right side, you have 6n. So let me carry on here. So on the left side, you have 310 plus 2. It will give you 312, which is equal to 6n. So you divide by 6 on both sides, and then here you will have n is equal to, what is 312 divided by 6? It will be 52. You can check that with your calculator. So n is equal to 52. So which term of the sequence is equal to 310? So that will be T52. We have solved the question. And let's move on to the next example, example number 5. Okay, example number 5. Given the arithmetic sequence 1 minus p, 2p minus 3, p plus 5. So this is an arithmetic sequence. This is your first term, or T1, and this is your second term, T2, and this is your third term, T3. So it's given with some letters. So the sequence is given with some letters, and we are told that it is an arithmetic sequence. So when you are told that it is an arithmetic sequence, you know that there is a common difference that is constant. So question A says determine the value of p. We need to find the p inside there. So I'll say solution. What is p? So remember, we can find the difference here. We can use the formula of finding the difference, the common difference, to find the value of p. Remember that T2 minus T1, so the next term minus the previous term, is equal to the constant or the common difference. and T3 minus T2 is equal to the common difference. So if I was to write it, it will be D, which is the common difference, will be equal to T2, that is 2P minus 3. I'm putting everything in the bracket. So this is T2 minus T1. This is T1. I'm putting everything in the bracket. It will be 1 minus P. And this must be equal to, because it is a common difference that is constant. So this must be equal to T2. And this is T, no, not T2. It's T3 rather. And T3 is P plus 5 minus T2. So T2 is 2P minus 3. So it is T3 minus T2, or T2 minus T1. So and it is equal to D, D being the common difference. So let's solve for this. So it will be 2P minus 3, and you have negative outside of the bracket. That means the negative is multiplying everything inside the bracket, so the sign will change. So there's a positive in front of 1, so the sign will change, it becomes -1, and here the sign change becomes positive P equal to P plus 5, and there's a negative, the negative is multiplying everything inside the bracket, so the sign will change, it will be negative 2P plus 3. Okay, so you have 2P plus P, it will give you 3P, and -3, -1, it will give you -4. Now you have P minus 2P, so it's 1P minus 2P, and this will give you -P. You have 5 plus 3, so it will be plus 8. And I'm bringing this -P to the other side so that it can go together with the 3P. So it will be 3P plus, when the -P change the side, it will be 3P plus P. It will be 4P equal to 8 plus 4. When the -4 goes to the other side, so it will be 12. And you solve for P, you divide by 4 on both sides. So P will be equal to 3 when you divide by 4 on both sides. Okay, so P is equal to 3. And now let's do question B. And now question B says determine the values of the first 3 terms of the sequence. So we need to determine the first 3 terms. What we can do is just to substitute for P. We have found P. P was equal to 3, as we found it in question A. So the first term will be 1 minus P. P is 3. And the second term will be 2 times P, which is 3 minus 3. And the third term will be P plus 5. P is 3 plus 5. Okay, so 1 minus 3 is -2. And here you have 2 times 3, which is 6, minus 3, it will be 3. And 3 plus 5, which is 8. So the first 3 terms are -2, 3, and 8. So those are the first 3 terms. So we have solved for question B. Okay, I think this is all for this video. And remember to subscribe to the channel if you haven't, and activate the notification bell button so that you can be notified every time I post new videos. Okay, I'll be posting new videos regularly, and you should expect to see lesson 2. We should have 6 lessons on sequences and series. Okay, this is all for this videos. I hope it was helpful, and see you in the next video.